Hi friends, hope you have gone through my previous videos in machine learning. Today in classical and temporal models we are going to look into a new topic. So today we are going to discuss about the Naïve Bayes classification. So already we have seen in the previous video what is Bayes theorem. Anyway, once again let me explain it. So the Naïve Bayes classifier, it works based on the conditional probability which has been explained by Bayes theorem. So what actually this Bayes theorem says is, it gives us the conditional probability of some event A given that event B has occurred. So how it gives us using the probability function, that is P of A by B is equal to P of B by A into P of A divided by P of B. So this is the probability function which explains the Bayes theorem. So now here P of A by B, it gives the conditional probability of A, that is the occurrence of event A given event B, and P of B by A, it gives the conditional probability of B given A. P of A is the occurrence or probability of occurrence of event A, and P of B is the probability of occurrence of event B. So these are the terms related to this particular probability function as explained in the Bayes theorem. Now let us consider an example, the normal probability example of tossing a coin. So here you are going to toss two coins and let A be the event that the second coin is head and B be the event that the first coin is tail. So this is the probability which we are going to identify here. So now using the Bayes formula, so P of A by B is P of first coin being a tail given the second coin is head, that is B by A, and P of the second coin, the probability of second coin being head divided by the probability of first coin being tail. So this is the probability function according to the Bayes theorem for this particular case. Now let us substitute the values. As you know, the first coin being tail given the second coin is head, it is the probability is 1 by 2. Similarly, the second coin being head, the probability is 1 by 2, and first coin being tail, the probability is 1 by 2. So substituting the values in the probability function, you will be getting the value 0.5. So now we are going to use that Bayes theorem into this Naïve Bayes classification, and this falls under the classification function, where we are using this Naïve Bayes classification as you can use it in face recognition, weather prediction, medical diagnosis, and news classification. These are the major areas or applications where we can use this Naïve Bayes classification mechanism. So now, based on the Bayes theorem, the Naïve Bayes classifier gives the conditional probability of any event A given that the occurrence of event B. So let us look into how it works. So for that, let me consider a problem statement to predict whether a person will purchase a product on a specific combination of day, discount, and free delivery. So this we are going to do using the Naïve Bayes classifier. So what are all the variables here when considering day as an independent variable? So here you have three different variables, that is weekday, weekend, and holiday. So the purchase may change based on these days, that is weekend there will be a different type of purchase, weekdays there will be different, and holidays there will be different. So for any given day, check if there is a discount and free delivery. So this is the thing we are going to classify now. So I have given you a small example with a data set. So here we have different customers whose details has been given, and their method of purchasing has been recorded in this data set. So with this small data set, we are going to try this classification. So based on the data set containing the three input types, the day, discount and free delivery, the frequency table for each attribute should be created. So the frequency table will be looking like this. First, consider the frequency table for discount. Those are having a purchase based on discount. So buy is yes and discount is yes is 19. Buy yes without discount is 5, and with the discount not buy is 1, and no discount and no buy is 5. Similarly, you can look into the frequency table for the free delivery as well as the frequency table for day. Based on these frequency table, you are going to classify the purchase rate. So for that, for using the Bayes theorem, now we are going to find, let the event buy be A and the independent variable discount, free delivery and day be B. So the A you are considering as buy, and the independent variables discount, free delivery and day you are considering it as B. So now these three variables, discount, free delivery and day, you are going to relate it with the variable A, that is buy. So now we need to calculate the likelihood for one of the day variables, which may be weekday or weekend and holiday. So the likelihood table will be like this. So here you could see that yes is 24, the total yes is 24 and total no is 8. Similarly, you can calculate for total weekday is 11, weekend is 8 and holiday is 11. Based on these, you are going to create the likelihood table. So in the likelihood table, what you are going to do is the weekday, the first one, consider that the weekday is 9 there, and in the likelihood table you need to consider it as 9 by the total number of buys. So 9 by 24. Similarly, for weekend it is 7 by 24, and then holiday it is 8 by 24. Similarly, we have done for all other values. So the same thing, likelihood table, we need to create it for other two variables like discount and. So based on that, you can calculate that there are 11 weekdays, 8 weekends and 11 holidays. So the total number of days is 30. So in that, 9 out of 24 purchase on weekdays, 7 out of 24 purchase on weekends and 8 out of 24 purchase on holidays. So based on the above likelihood table which we have created, we could find the probability of purchasing on weekday, that is P of B is equal to 11 divided by 30, which is 0.37. Similarly, not making purchase, you can find that 6 divided by 30 is 0.2. So that you could identify the value of P of B by A, that is weekday no buy, it is 2 divided by 6 is equal to 0.33. All these values we will be getting from the likelihood table. So now we could find the probability of the weekday without a purchase. How we can do it is using the Bayes formula, that is probability of weekday with no purchase into probability of no buy divided by probability of weekday, that is 0.33 into 0.2 divided by 0.37, which is equal to 0.18. So as the probability of no weekday is less than 0.5, the customer will most likely buy the product on weekday. So they are most likely to buy product on weekday. So we have the frequency tables of all the three different variables, and based on that we are going to construct the tables for all three variables. So like what we have seen for the frequency table for day, I have created for the discount as well as for the free delivery using the same mechanism which we have already seen, and based on that you are going to classify the variables using the Naïve Bayes classification. So here the likelihood tables can be used to calculate whether the customer will purchase the product on a specific combination of the day when there is a discount and whether there is any free delivery. So consider the combination as a small combination which we are going to try in this particular session is B equals, that is day is equal to holiday, there is discount and there is free delivery. For this case we are going to calculate we are going to identify the probability of purchasing the product. So day is equal to holiday, discount is yes, and free delivery is yes. So how we can do it using this is the probability of them not purchasing. So P of A by B is equal to P of, that is the probability of no buy with discount is equal to S, free delivery is equal to S, and day is equal to holiday. This is the condition which we are going to find it. So this I am separating into the various separate group using the same Bayes theorem. So probability of no buy by discount is equal to S, that I am splitting like this, which is mentioned using the yellow divided by the entire combination of this discount is equal to S, delivery equal to S, and day is equal to holiday. So now substituting the values, you will be getting it as the value is 0.178. So now we need to find the probability of them purchasing a product. So P of A by B is equal to S by, then discount is equal to S, delivery is equal to S, and day is equal to holiday. So which on substituting all the values you are getting it as 0.986. So now we are going to normalize these probabilities, that is sum of the both probabilities is 1.164, which is not possible, that the sum of the probability should be 1. So we are removing that 1.164, so that while normalizing, the likelihood of purchase is equal to 0.986 divided by 1.164, which is 84.71%. And similarly not purchase is 0.178 divided by 1.164 is equal to 15.29%. So this is the percentage chance of buying and not buying the product on the particular day, that is holiday, with the discount and with the free delivery. So we conclude that the average customer will buy on holiday with the discount and free delivery. So it is around 85%. So this is how we can use the Naïve Bayes classification for the classification purpose.